Nikola Tesla and his conquest of Niagara Falls. Conquest of Niagara was by no means assured.
It hinged on very specific factors. The first serious scheme to harness the mighty cataract, the Evershed Plan, was proposed in 1886. Thomas Evershed, a civil engineer, who had worked on the Erie Canal, had conceived the idea of the creation of a complex network of canals and tunnels running adjacent to the falls, whereby 200 water wheels and accompanying industrial mills would be placed. He had probably ruminated over the scheme for 20 years, as Evershed had worked as a surveyor at Niagara in his youth as far back as the 1840s.
Although the idea was attractive, it was costly and dangerous to implement, as most of the 9 miles of excavation required for the canals and wheel pits had to be done by blasting through stone. Estimates ran as high as $10 million. Thus, the officials of the Cataract Construction Company sought counsel from notable engineers and inventors. In 1889, Edison submitted a plan which boldly asserted that DC could be transmitted to Buffalo, approximately 20 miles away, as appreciable amounts of DC electricity had never traversed a distance in excess of 1 or 2 miles. This suggestion appeared highly optimistic, and it was doubted by most other engineers, particularly Sprague and Kennelly, 2 of Edison's co-workers.
Westinghouse was also dubious of the feasibility of transmitting electrical energy, and he suggested the implementation of a sophisticated system of cables and compressed air tubes to transfer the power to Buffalo.
Thus, for these reasons, plans for harnessing the falls centered for the most part on constructing an industrial complex adjacent to the falls.
The long-distance transmission of electrical power was simply beyond imagining.
It must be remembered that what Edison generated was meager amounts of electricity capable of illuminating light bulbs, and then only in close proximity to the source of the power.
Since his DC apparatus still made use of a commutator, he was incapable of transmitting appreciable amounts of power, although he could run a few motors if they were close to the generator. That is why the 1891 Lauf and Frankfurt transmission was so startling. Brown and Dobrowolski had not only surpassed, by a factor of about 100, Edison's long-distance record, they had also transmitted significant amounts of power, a spectacular achievement with no comparable precedent. Brown and Dobrowolski had had predecessors. 2 years earlier, Sebastian Ziani di Ferranti, the son of an Italian musician living in Liverpool, England, had been the first to use Tesla's apparatus at a plant at Deptford. Ferranti, a brilliant engineer with talents purported to have rivaled Edison's, had already made important modifications on the Corlett Gibbs AC apparatus for Siemens Brothers and also Gantz and Company at their London branch. His bold idea was to create a central station along the Thames so that electricity could be pumped to numerous substations around town. In 1889, from Deptford, Ferranti transmitted an unprecedented 11,000 volts to 4 substations of 6 to 7 miles away, where 10,000 horsepower alternators were driven. This was a magnificent accomplishment, but it appears doubtful that many people understood that it was Tesla's system or even that true success had been achieved. In no way did it gain the publicity of the Lauf and Frankfurt enterprise, nor did it spark the idea of spreading the energy of Niagara Falls beyond its surrounding area. Nor had Westinghouse's initial achievements in electrical power transmission demonstrated the capabilities of the Tesla system.
He had succeeded at Telluride, Colorado, with Stilwell, Schallenberger, and Scott in transmitting 60,000 volts of AC for a distance of 4 miles to run a 100 horsepower Tesla motor. And he had illuminated the Chicago World's Fair of 1893.
Both of these were great triumphs, but neither demonstrated that electrical power could be transmitted over long distances. In short, without the Lauf and Frankfurt success, there would have been no proof that AC was capable of traversing the 20 miles from Niagara to Buffalo, let alone from Niagara to New York City, which was over 300 miles away. That is why the financial backers of the Niagara project sent Edward Dean Adams, president of the Cataract Construction Company, to Europe to confer with Brown and Dobrowolski, and that is why Dobrowolski intimated that the invention was his. There was no physical proof to the contrary, as clearly he and Brown had been the first and only engineers to realize such a feat. Adams, from the firm Winslow, Lanier and Company, out of Boston, was a slight, gentle-looking man with large round eyes, small head, the face of a teenager, and a mammoth handlebar mustache. He began his relationship with Longtimmy P. Morgan associate Charles Lanier in 1881. Working his way up to full partner, Adams was placed on the board of directors of a number of major railroads, including Henry Villard's Northern Pacific, and also the Ontario and Western Railroad, with lines stemming from Buffalo to New York City.
He also sat on the board of directors of the Edison Electric Light Company, as its second largest stockholder.
In 1889, along with Villard, who was attempting to combine all the major electric companies into one large corporation, Adams tried to curtail the highly expensive libel patent dispute between Edison and Westinghouse by getting them to confer with one another. But, of course, Edison wanted no part of such an arrangement.
As president of the Cataract Construction Company, Adams sold his shares in the Edison concern so that he could be impartial in his investigations, and in 1890 he established the International Niagara Commission, with headquarters in London.
His intention was to consult with leading European scientists and engineers and to examine the most advanced hydraulic power compressed air techniques, a branch of engineering in which Switzerland excelled. In 1890, Adams traveled to Europe with Dr. Coleman Sellers, another executive of the Cataract Construction Company, where they conferred with engineers in France, Switzerland, and England. In London, they visited Ferranti at his electrical station at Deptford. They also met with Professor Rowland, who had travelled from Johns Hopkins University, and Gisbert Kapp, electrical engineering editor and author of the classic text Electrical Transmission Overture.
Rowland argued in favour of AC, and Kapp recommended C.E. Elec Brown as the most prominent engineer to undertake the project.
He was located at the Maskinenfabrik Oerlikon works in Switzerland.
Adams wired J. Pierpont Morgan, who was in Paris, with the suggestion that he return to Switzerland to meet with Brown. Morgan conquered. Before leaving England, Adams met with Sir William Thomson Lord Kelvin, whom he placed in charge of the International Niagara Commission, and a contest was created awarding cash prizes totaling $20,000 for the best plans submitted for harnessing the falls. Elec B. in Stilwell, who was in London with H. Bilsby, at the Westinghouse branch, wired to Pittsburgh to request permission to compete by giving Adams a plan based in the Tesla system. But Westinghouse turned down the idea because he did not want to give away $100,000 worth of advice for such a paltry sum.
Of the 20 proposals submitted, most involved compressed air and hydraulic equipment.
Of the 6 electrical plans, 4 used direct current, 1 proposed single-phase AC, but details were not fully described. The remaining plan by Prof. George Forbes advocated polyphase installation.
Forbes, who was a professor from Glasgow and who was later hired as consulting engineer to the Niagara Power Company, wrote to the Commission, "It will be somewhat startling to many, as I confess it was at first to myself, to find as the result of a thorough and impartial examination of the problem that the only practical solution lies in the adoption of alternating current generators and motors. The only workable one is the Tesla motor manufactured by the Westinghouse Electric Company, and which I have myself put through various tests at their works at Pittsburgh."
Although initially rejected by the Commission, the Forbes report caught the eye of Adams.
Nevertheless,
Adams went to Switzerland to confer with C.E. Elec Brown, who declined the offers to head up the Niagara project.
Morgan's emissary was Francis Lind Stetson, a lawyer who was also part of the Cataract Construction Company.
He was sent to Switzerland and London to review the prevailing technology for their company, GE, but it was starting to become obvious that the major patents were all owned by Westinghouse.
In Tivoli, where there were waterfalls 334 feet high, Gantz and Company of Budapest, another Westinghouse-linked operation, was constructing a hydroelectric plant to transmit electricity to Rome, which was 18 miles away, and in Portland, Oregon, at Willamette Falls, Westinghouse was also transmitting thousands of volts of AC over distances of 12 miles.
Although Kelvin sided with Edison in insisting that DC was superior, Adams now knew that Westinghouse held all the trump cards. In America, however, and from the point of view of GE, the outcome was not all that obvious.
The Panic of 1893 had taken its toll, and Charles Coffin, CEO of GE, was forced to ruthlessly lay off a large number of their workers and cut the pay of many others.
Not only had production of electrical equipment fallen dramatically, infighting between the Edison and Thomson camps peaked. Although Thomson and Steinmetz now realized that AC was vastly superior to DC, they were unable to guarantee to Coffin that they could devise equipment superior to Tesla's.
Desperate to compete, it appears that a memorandum was sent by Thomson to GE Quarters, general manager of the GE plant in Pittsburgh, for the purpose of recruiting an informant who worked for Westinghouse, admitting that blueprints were missing. Westinghouse accused G of industrial espionage, and charges were brought against Thomson's Lynn plant, where a sheriff, acting under court order, found the missing documents. The G officials claimed that their interest was in seeing whether Westinghouse was pirating their protected light-bulbs, and Thedgery split 6-6 on the decision. Westinghouse suspected that a janitor was the culprit, but the man was never prosecuted.
Simultaneously, Steinmetz and Thomson were submitting patent applications for an AC motor which used a teaser current instead of a full-fledged polyphase one. But it was obvious to the patent office that the apparatus was based on the Tesla system, and their patent application was denied.
This did not stop Thomson from insisting that he was the real inventor of the AC system, and by 1894, with Thomson's great expertise, he devised an induction motor that in some respects was superior to the one produced by Westinghouse.
Ironically, even to this day, biographies of Elihu Thomson often accuse Tesla of the piracy instead of the reverse. Although G was brought to trial for stealing blueprints, they audaciously continued for the next several years, through waters, to pay spies to obtain information from the Westinghouse plant.
Nevertheless, Westinghouse's success at Telluride and at the Chicago World's Fair eliminated any remaining doubts as to who would be awarded the Niagara contract. In the first months of 1893, Forbes, Rowland, and Sellers visited Pittsburgh to test their equipment, and in May of that year, the deal was signed with Westinghouse, ASJ.
Pierpont Morgan was the major force behind GE. It is interesting to speculate about why he allowed Westinghouse to gain the bid.
First of all, when the actual contract was signed, because the operation was so enormous and because of Morgan's ties to GE. A large portion of the work was also given to GE.
Westinghouse constructed the generators, switchgear and auxiliary equipment in the powerhouse, and GE was awarded contracts for the transformers, the transmission line to Buffalo, and the equipment for the substation there.
Thus, although Westinghouse got the larger share, GE was by no means cut out and in fact ended up with a licensing arrangement which gave them their first legal foothold on the fundamental patents held by the other company. Morgan had close ties to Auguste Belmont, who was one of Westinghouse's financial backers, and it is possible that this connection had something to do with the arrangement.
He acquiesced in part because of his respect for the commission Adams had set up and also because of the advice he received from his lawyer William B. Rankin, who lived in Buffalo, and who had devoted his life to the enterprise, and his close associate, Francis Lynn Stetson, who told Morgan of Tesla's daring promise as far back as 1890 to place 100,000 horsepower on a wire and send it 450 miles in one direction to New York City, the metropolis of the East, and 50 miles in the other direction to Chicago, the metropolis of the West, to serve the purpose of these.
In 1894, Tesla hit his stride. The Martin article in the Century opened the floodgates, and an army of reporters from newspapers and magazines descended upon him. That you would find features on Tesla in such prestigious periodicals as New Science Review, Outlook, and Cassius, McClure's, and Review of Reviews boldly announced that Tesla was the founder of the discoveries which lay behind the largest electrical enterprise in the world, and the New York Times profiled him in a 4-column spread complete with a large stylized portrait and an in-depth account of his philosophies and newest creations. The following year, the Times wrote, "To Tesla belongs the undisputed honor of being the man whose work made this Niagara enterprise possible. There could be no better evidence of the practical qualities of his inventive genius. Since the contracts with Westinghouse and GE had been signed, Adams no longer had to pretend to be unbiased. Now he was free to seek business ventures."
He came down to New York to visit Tesla at his laboratory, and there Adams was introduced to the inventor's new mechanical and electrical oscillators, and to a revolutionary new AC system of lighting that was vastly superior to the existing one. Adams offered Tesla $100,000 for a controlling interest in 14 US patents, many foreign patents, and any future inventions which Tesla might conceive. The inventor accepted the proposal 1.25 in February 1895. The creation of the Nikola Tesla Company was formally announced, with the directors being Tesla, Alfred S. N. Brown of New York, Charles Coney of New Jersey, William B. N. Rankin of Buffalo, Edward D. Adams, and Adams's son Ernest of Boston.
Tesla had reached the inner sanctum of the corporate world.
He now had on his board two of the most important members of the Niagara project, and he was sitting on at least a half dozen entirely new inventions, each of which had the potential for creating completely new industries.
His mechanical oscillators looked as if they were going to replace the steam engine. His electrical oscillators were intrinsic to his system of fluorescent lighting, remote control, and his now secret work in wireless transmission. And there were other ideas as well, such as his work in artificial intelligence, ozone production, cheap refrigeration, and cheap manufacture of liquid air, the manufacture of fertilizers and nitric acid from the air. However, all of these inventions were still, to a great extent, in their developmental stages, and Tesla's strong suit was never in manufacturing. He gained his backers ostensibly because of his track record in AC and because of the premise held by his cold light and various oscillators. But his real interest, his passion, remained in the wireless transmission of power, and most of his time was spent in that direction. End of Nikola Tesla and his conquest of Niagara Falls. Thank you for watching.